Okay, welcome back, Team Resistance, to Logic 2. We covered the first two items, improving the existing code and logical operators and or not. And now we're going to code and implement the following sequence and demo it with the simulator. So let's get started. All right, so let's code a new sequencer. Remember, this is an interlock, and this time we're going to do some fancy switch ups between the buttons. Now I could write it here, right? Oops. Right. I could highlight this and do a control slash. And it would comment it out, and I could write some new code under teleop periodic. But I tell you what, I'm going to leave it there, leave this interlock going. But we control what mode we're in. We control the horizontal, we control the vertical. So we're going to control teleop or autonomous or test, right? So why don't we put our code in autonomous periodic, and we'll run our autonomous mode instead of teleop mode, right? Pretty simple. I'm going to cheat because what's the first thing we want? Comments. So we know what this code's supposed to do. If all the DIs are off, the DOs are off. If all the DIs are on, all the DOs are on. If a DI is on, the associated DO is on, all others are off. If two DIs are on, the unassociated DO is on, and the others are off. A little change up. So let's think about this for a moment. What do we need to be true for the red LED to be on? Right? That's what we're asking. Because again, we know it's Boolean. It's true or false, right? On or off. So if we determine what's true when it needs to be on, then we know when it needs to be off, right? So let's figure out what we need to be true. So if, right? Well, what needs to be true? The first statement is all DIs are on, all DOs are off. No, sorry. All DOs are on. Sorry about that. Make sure your comments are right? So what do we need to check? We need to check the red button, right? .get. And since it returns a true false, don't really need to check it against anything, right? We just need to check it against the other ones. Well, we need to, if the red button is on, true, and the yellow button .get, right, is true, and right, the green button is true, right? Then we want the red LED to be on. All right, so red LED dot set true. And you need the semicolon, that's the end of the statement. Else, right? You said it's two states, so else the red LED is off. Right? Well, wait a minute, those aren't the only things that can turn on the red LED. Red LED, if the red button is on, then we want the red LED to be on. Right? So how do we do that? Well, we could write another if statement, but a better way to do it would be to combine logic here. All right. I'm going to cheat here. I'm going to copy this. Control C. Control V. Right? And we're saying if the red button is on, but the yellow button is not on, right? And the green button is not on, right? But there's some errors here. Well, there's no, this is one statement, right? This is one check. This is another check. So it's and this, and this, and this, or this, and this, and this. So to make sure that we understand our logic, we're going to put this in parentheses. All right, that tells the compiler, do this check as one item. Then we're going to put this in parentheses, right? And we're telling the compiler to do this as a check, right? Well, we still are having an error here because we've said do this as one and do this as one, but we haven't said what to do between them. So what we want to do is an OR statement. There you go. So we check this is true or this is true. Turn on the red LED, else turn off the red LED. All right? Well, wait a minute. There's more. What if we've got the second one, which is if two DIs are on, the unassociated DO is off. All right? So when does it want to come on? Well, it wants to come on if right, and we need the OR, right? So when does this last one? If the two DIs are on, the unassociated DO is off. Well, that means if the red is not on, right, and the yellow is on and the green is on, right, so those two have been pressed, the red hasn't, then the red LED comes on, right? Pretty basic stuff. Whoop. Not basic, it's interesting. All right, so we've done the red LED. We've said, told the compiler with these enclosed parentheses, do that as a check. Any button, all buttons on, do it. Well, you know what would be nice? Some comments. All buttons pressed. All right, what's this line cover? A, associated. Pressed. And finally, I don't know, unassociated. Buttons pressed. right? So there's how you do some sequencing. What do we do next? You betcha. Just copy this, Control C. Let's put a little space in here. I like spaces. I like some readability. Right? Forgot to copy the comment, so let's add a comment. The green, this is the yellow LED control sequence. This is the green LED. Well, this is the yellow LED. Again, if they're all pressed, then go ahead and true. If only the yellow button is pressed, so all we needed to do was change that. Green doesn't need to. Only the yellow button is pressed on that one. On this one, only the yellow button is pressed, right? So we can swap those around. Boom. Now the only thing we need to change is what LED we're running, right? So we'll change that to yellow, and I can certainly type YEL. Sorry about that. All right. How about the green one? Yeah, we don't need to change. Again, all buttons pressed, turn on the green one. If just the green is pressed, right, and the other ones are not. If the green is not pressed, but the other ones are, then turn on the green LED. All right. I think that's got it, right? And again, we've put that in autonomous. So what are we going to do? We're going to do a Control S to save it. We're going to come up, run our simulator. The build is successful. Our HAL GUI, let's launch it. All right, so all buttons are pressed. Oh, wait a minute. Let's come over here now. And again, not teleop, we're in autonomous mode. So let's run autonomous. All are high. So if we turn off the red LED, right? The red LED stays on because it is not one of the two that are high. It's the unassociated ones. And the other two are low. Good so far. Let's make the yellow low. Again, now the only one that's on is the green, and the only LED on is the green. If we turn the green off, all of them go off. Well, let's go around the other way. How about if we turn this one on high by itself? That's the red. The red is on by itself. If we turn on the yellow, they both go out, and only the green, the unassociated one, goes high. So we can go through and check the rest of this, but I think it's all good. I know it is. I've tested it. But again, if we were running a real robot, we'd probably want to check them all combinations. All right, so we're just about finished here. I'm going to give you a challenge in a second. So hang in there. All right, so the challenge is if all DIs are off, all DOs are off. right? That's the same as the original one. However, if there's an even number of DIs pressed, turn on the green LED. If there's an odd number of DIs pressed, turn on the red LEDs. Be constructive, be patient, be flexible. Things are changing. They always are. Next time around, we're going to add some functions, some troubleshooting. So have fun, enjoy yourselves, and we'll see you next time.